being here today. It's a great honor for me to be able to share my ideas with you and share my ideas in honor of Pete. I'd like to say a few words about him to kick us off and to transition into what I have to say. He earned a PhD in engineering in 1965 from Cornell University and has spent the subsequent years as a faculty member doing his research. Bear with me now when I read some of his recent papers. He's interested in decision support systems, water resource conflict resolution, the role of modeling in water planning, the economics of biodiversity, societal responses to natural hazards, the economics of floodplain management, water for urban renewal, and the challenges of managing water under uncertainty. I took a look at his resume, and as I read those things, I thought, I'm interested in all of that. So I hope I'll do him justice today. But I think, and as I looked at his career, what I saw was him moving from deep analysis to putting disparate pieces of the water picture together. I saw him moving from analysis to synthesis. And you know, in my opinion, with the big, complex world water problems that we experience, the capacity for synthesis it is critical to being able to solve these problems. I met Pete for the first time in March because we were together on a National Science Foundation workshop in Annapolis, Maryland. And the purpose of the workshop was how do we integrate stakeholders more effectively into water modeling activities. How do we get them to use the products of our activities, and how do we engage them in the modeling processes themselves? I have to tell you that at age 84, Pete was the first one to write a blog. When you go to a workshop now, you blog, because this is the way we communicate our ideas to wider audiences. He went home the first night and wrote one. He was the first one to share his case studies with the group, and he certainly had a lifetime of insight in working with watershed groups in water modeling and decision making. So I feel blessed, in fact, to have the opportunity to share my ideas in his honor today. I think that the kind of moral of my story is that I think in the original topic, or the original title, I had why we need a new paradigm for water resource management. I'll start with this idea and then end with it. But what I'd like to do is to build a case for the fact that prediction and optimization will not be able to get us to making the big decisions that we need to make in water resources management. That there are some other paths, decision making under uncertainty, anticipation. We're solving the difficult issues where people and societies have to make trade-offs, and conflict resolution and the engagement of stakeholders as partners in our activities is an important theme, I think, of what I'd like to talk about today. I'd also like to give you a brief history of the Decision Center for a Desert City, because I'm proud of it, but also because I think it's part of my narrative. I'm not by training a water scientist. I'm not a hydrologist. I am, in fact, as Siva said, I'm in urban geography. And I kind of came into an interest in water resources management from the back end. If you're interested in the urban geography of a desert city like Phoenix, you have to be interested in water. It is a definition. It helps us understand the history of the place, and it's absolutely critical for us understanding the future of the place. So my experience has been very much in water has been very much molded by my leadership of the Decision Center. I'd like to tell you a little bit about that. I'd like to tell you a little bit, so I'm a geographer and I can't help myself. I want to tell you a little bit about the geography of Phoenix and the water challenges that Phoenix faces, the kind of challenges that have motivated our work in water resources management in Phoenix. I'd like to argue that the challenges that Phoenix faces, and indeed many of the world challenges in water management, are decision-making under uncertainty questions. And there are procedures that we can follow with DMUU problems. What kind of lessons that we've learned from being a boundary organization? I'll say a few words. A boundary organization, in our thinking, operates at the boundary of science and policy. So what can we learn from decision makers that can help us in our model building activities? And then I'd like to show you a case study that we just recently did, and it will be coming out for publication in the next month or so, where we simulate a mega drought condition in Phoenix. And would Phoenix survive a mega drought future? And what do we need to do now? What are our adaptation strategies so that we could survive at reasonable lifestyles and with an adequate population under conditions of mega drought? So that's the plan for the day. DC. I saw a request for proposals from the National Science Foundation in the United States, and it was from the social science. I am by training a social scientist. It was from the social science division of NSF under a program called Decision Making Under Uncertainty. And here was the premise of the request for proposal. We have, as a nation, put hundreds of millions of dollars, I hope I'm not hurting any of your feelings here, into climate research. And we're not very good at adapting to climate change. We're not very good about making climate-based decisions, despite the fact that we have spent these hundreds of millions, into billions of dollars on climate research. So let's throw some tens of millions of dollars at social science and challenge them to ask a different question. And that different question is, how do we make better decisions in the face of inevitable uncertainty about the climate? Instead of reducing uncertainty, instead of closing the envelope of variability, what can we do as a nation? What can we do as societies? What can we do in Phoenix to better prepare ourselves for the uncertainty of climate change? So we changed the question. So my group came forward and said, well, we'll take a shot at this in Phoenix, and we'll take some of the ideas that we know exist in social science, and we'll try to synthesize, we'll put them together in a way that will aid decision makers in being prepared for whatever the future is. And part of our research strategy is to use simulation modeling and to ask what-if questions. What if there's a negative? What if we were to experience the same kinds of drought conditions that existed in the 1100s, in the 12th century in Phoenix? If we were to reproduce those in Phoenix now, what would it mean for us? What would it mean if we reused all of our water currently? What would it mean if we reduced the rates of population growth? And begin to use our models to ask ask those what-if questions. How effective would particular policies, how much risk reduction would particular policies provide for us? And then finally, we conceptualized ourselves always as a boundary organization. Not social scientists, not climatologists, working separate from our community, but we made good friendships with the water managers in our community. We invited them in every 2 weeks. We invited them to review our models. We asked them what their needs were for climate adaptation and how we might be of some help. The picture on the left in front of you is that we invited the designers of the big climate models in the Western United States, the University of Washington, NCAR, to come and talk about climatic uncertainty. And the rest of the room is filled up with water engineers from our local communities. So we wanted to be able to have people in the community to have a understanding, firsthand, on the ground, understanding what the climate models were arguing about, parameter. What sort of parameters should we use for these estimates? And it was something of an education. We also, in creating a boundary organization, decision theater, it inspired us to try to visualize our model, to make it more digestible for the decision makers. I don't know that we've got 10 years of record, and I think we now know what not to do, and we've made some progress with our model. But what are the key variables that we want to show? How do we want decision makers to be able to manipulate our model in real time? But the picture on the right gives you a little picture of our decision theater and how we attempt to show the results of our model. And in a what-ifing kind of model, people ought to be able to press lever bars to alter policies and to see the outcomes in real time. So I think that would be the decision theater and the capacity to visualize the model, and the investment in the willingness to invite people from the community. I don't claim that we have all the answers, but we probably made most of the mistakes. And I'll share some of those with you as we go through this. But let me set the stage. So what we're doing is trying to build an adaptive capacity for the desert city of Phoenix. A little bit again. You're catching the geography part of me. Phoenix in the southwestern. In the southwestern part of the United States, you have a city of 4 million people in the northern reaches of the Sonoran Desert because it has a large hydraulic reach. So Phoenix receives water from the watersheds immediately north of it, about 40% of our annual water use. We have an allocation of the Colorado River. So I tell the public in Phoenix, you shouldn't be worried about climate change in Phoenix. We're interested in climate change in Wyoming and in the whole Colorado River Basin, because that's where our water is coming from. So we get about 40% of the water for the metropolitan region as a whole from the Colorado River Basin, and then sitting underground underneath Phoenix is a large sedimentary aquifers, and so we get about another 20% on average water from underground sources. So a large hydraulic reach for Phoenix. A large amount of water. This is the way it looks. Phoenix is not a desert city. Phoenix is an oasis city. It has recreated the landscapes of the Midwestern and Eastern United States. And this is what an upper middle class house might look like, and it takes a fair bit of water to be able to support that kind of a lifestyle. So it's a large hydraulic reach. We can call it a desert city, but it's really it's functioned over the last 100 years as an oasis city. 100 years ago, Phoenix was an agricultural region. So it was the third most productive agricultural county in the whole of the United States. Feedlots, citrus, alfalfa, cotton were all grown slowly over time, especially since the Second World War. This agricultural region became an urban region. As a social scientist, there's a fair bit of there are a large number of research questions that center around landscapes that look like this. I think we've done a fair bit of research on it's recreating these past landscapes. People have status built into these landscapes. Our psychologists have looked at why people choose to use water so abundantly in decorating the outsides of their homes. It gives them status, it gives them, they're thought to be more family oriented, they're thought to be cooler people. So the conservation and the moving away from these landscapes isn't just a matter of, gee, we've got to adapt to climate change, because of the huge amount of investment that there is in this lifestyle and in people's homes looking this way. Another, I think is interesting, social science question surrounding water. Social scientists spend a fair bit of time arguing about is water a commodity? And generally speaking, in Phoenix, it's a commodity as opposed to a human right. This is a big issue in the international water community. I show this to my students in water resources, and I tell them that we have very different attitudes about water in central Arizona, and I show you the water schedule, the water prices in Phoenix versus Tucson, which is in fact a desert city. In Tucson, the blue line, water for indoor uses, small amounts of water are very cheap. After you use the basic water for survival, it becomes very expensive. In Phoenix, we have no such blocked schedule associated with our water prices. They become a little higher in the summer than they are in the high season, the peak use during the summer than in the winter. But the first water for survival and for washing is actually more expensive than it is in Tucson. I think communities are expressing we express interest as individuals in what kinds of landscapes that we like, and the status that we gain and the meaning that we gain from them. The communities also express their values about water, I would argue, in the way they organize their rate structure, with Tucson more taking the view that water is a human right, in Phoenix regarding water use as a commodity. So places have different, and Phoenix has its own view of the value of water. I guess as a geographer, but also from my research, this tends to be one of the most important graphs or the most important maps that I have to show you. This is a map of the sources of water by water providers in Phoenix. We do not have one water provider for 4 million people. We have 120 water providers for 4 million people, about 40 large ones. And each provider has its own portfolio of supply. The green is groundwater, the buff is Colorado River water, which comes through the Central Arizona Project to Phoenix, and the Salt River Project, the purple, are the watersheds immediately upstream from Phoenix. So everybody has their own portfolio. Everybody has their own prices. Everybody has their own conservation program. So we don't face adaptation as a community of 4 million. We face adaptation as a fragmented decision-making unit. The downside of that is that we're not taking advantage of cooperation. So when one source is in deficit, we can pull from other sources if communities have the infrastructure and have the will to be able to cooperate with one another. Some of the regions and some of the cities on the western part of the region are using primarily groundwater. We've been able to show in our simulations that some of these communities are posed to do more in the future of undermine the risk of shortage of their neighboring communities. So we're imposing costs on our neighbors, and we're not exploiting the full benefits of opportunity. Well, you can imagine, how do we handle that? We game that. We put that into our water simulation model, and we game a cooperative structure and show the adaptation capacities of a cooperative structure in comparison to the competitive structure that now exists. I think I would say that these governance challenges are far and away the most significant challenges that Phoenix and other places have as they move forward and try to adapt to the uncertainty of climate on these different watersheds that I showed you earlier in the talk. In addition, we've got a metropolitan area that has grown very quickly since the end of the Second World War and is poised to grow even faster in the future. So you're not looking at the climate models extrapolated into the future. You're looking at the paths of growth in Phoenix, depending on whether we use high growth, medium growth, low growth alternatives. So for us, there are uncertainties in the climate system. There are uncertainties in the demographic system. How fast will we grow? From a policy standpoint, will we continue to encourage this growth? Certainly, there are uncertainties in the governance system. Will we cooperate or continue to compete with our neighbors as we think about how we're going to use our water moving forward? So rapid growth. The projections are we're 4.2 million people today, and anticipate being 8 million people in 2050. So you're going to put 8 million people in the northern rim of the Sonoran Desert. Will we have enough water to support that population if climate change were to reduce our water supplies on the Salt and Verde River, or if, irrespective of climate change, if we were to experience drought conditions comparable to what we experienced, what the region experienced some 2,000 years ago? Happily, we've been able, one of the pieces of good news is that we've been able in the recent 20 years, although it's only been, I think we've only been able to document it with enough evidence and assuredness in the last 5 years. That there's been a pretty consistent, despite the picture that I showed you of the heavy use of water for outdoor uses, the per capita water demand has actually declined over the last 20 years, as it has in almost every North American city. So we've brought the water managers from Seattle and Portland, Tampa, all over the country together to try to compare. This is our boundary organization function, to be able to compare notes to see if what we're seeing in Phoenix is in fact a North American trend. And what you pretty much see is this kind of trend of a pretty steady reduction. Sorry, I'm not used to it. A pretty steady reduction in residential household use since 1990. What happened in 1990, the United States passed the Energy Policy Act, where all new homes were required to have low flow toilets, efficient faucets, and low rental benefits of policy in water use in Phoenix and all across North America. So we've seen reductions of 1 to 1.5% a year as new homes are built and retrofits occur in older houses. We've seen this consistent decline in per capita water use. This is what's allowed us to grow over the last 20 years. So growth has been in large part provided for by the reductions by conservation, by reductions in per capita use. And I think we know we have enough time, and we certainly, in that you see it across almost all North American cities. I think we believe that this is a real trend. The cautionary note, though, for us, and something that we're giving a whole lot of thought to, is all this reduction that's taken place. So we believe that most of this reduction that's taken place has resulted from the decline in indoor water use. It's been policy driven. It's not something that people have changed their lifestyles and changed their ways of using water. To the best of our knowledge, outdoor water use, that house, with all the water that it takes to support the outdoor use, that still pertains. And we'll reach the point relatively soon where we will have gotten most of the indoor gains we expect to get. And now the hard part comes, because we have to take serious looks at outdoor use, which is a function of behavior, culture, status, deep-seated cultural values about what the city looks like and who we are and how we live. So we've been able to avoid that problem over the past 20 years and still be able to support growth. We don't think that, we don't know, that's not going to happen forever. So we're going to have to confront the outdoor water issue fairly soon. So the growth has been manageable for us in most cases because of the public response to policy, and it's almost a public unconscious response to policies. New fixtures and appliances were put in people's houses without having to make decisions that have real meaning to people. This is the iconic image that drives our discussion about water and the future of Phoenix. This is Lake Mead on the Colorado River. Lake Mead is one of the two large lakes on the Colorado River. That white ring is a bathtub ring, represents higher levels of storage than exist today. This is an important image to anyone who lives in the Colorado River Basin. It's an especially important image to Phoenix. And that is because water on the Colorado River is allocated to lower basin states, to California, to Nevada, and to Arizona. And in 1968, before any of us ever heard about climate change, Arizona agreed to take junior rights to Colorado River water if there was ever a shortage, and gave up the senior rights to the Colorado River to California. They did it to get California to vote for the bill to pay for the infrastructure to build the Central Arizona, to build an aqueduct across Arizona that delivers water from the Colorado River to Central Arizona. They didn't know in 1968 they were giving up the rights to the Colorado River, or they might be giving up the rights to the Colorado River. So as that bathtub ring falls, so also does Central Arizona's, so rises Central Arizona's probability of taking shortage on the Colorado. The exact number is 1,075 feet, and the Lake Mead has been hovering between 1,075 and 1,089 for the last 4 or 5 years. We all know it's inevitable, and so we're going to experience the full brunt of the shortage of Colorado River flows from climate change, from drought conditions, and we're going to need to get ready to resolve it. But it's this kind of an image that it appears in our newspapers like twice a year. Lake Mead is down to 1081, and then stories are written about it. It's an immediate, it's a visual whammy that attracts people to the issue of water, and can we continue to grow in the face of uncertainty about the climate, and in the face of the vulnerability of our situation for one of the 3 major water sources that we depend on. So what we've come to believe is that the water problem in Phoenix is a problem of deep uncertainty. And when people talk about deep uncertainty, they're talking about wicked problems. Oftentimes that term is used. Wicked forces or wicked problems have 3 characteristics: the fundamental driving forces that shape the future, and the models that describe them. There's fundamental disagreement about what are the driving forces that shape the future: climate, growth. Governance, growth, climate. All 3, which one is the most important? How would you prioritize them? In our world, there is fundamental disagreement about the relative importance of the forces that will influence future water supplies. The probability distributions used to represent uncertainty and the key variables and parameters. To be sure, we live in an era of non-stationarity, and whether the models that served us well and the empirical observations that served us well over the last 100 years will serve us over the next 100 years is certainly in question. And how to value alternative outcomes. You know, there are always winners and losers, and winners and losers will be part of this debate. Ironically, one of our Native American communities is one of the biggest water rights holder. So a shortage will actually increase, if you believe water is a commodity, will increase the value of their water rights. So this whole issue of water and growth are seen is a very contentious issue in Phoenix. And what the people who come from a field like decision-making under uncertainty, economists, decision scientists, argue, and I alluded to in my beginning remarks, is you have to ask different questions. We can't ask anymore what's the best future for Phoenix. What's the most likely future for Phoenix? But rather we change our questions. This doesn't mean that there isn't a role for science and scientists and hydrological modeling and climate modeling. But the question on the table comes to be, what kind of future do we want? And what kind of decisions do we need to get there? Those are different kinds of questions than the kinds of questions, for the most part, we've asked in the water sciences. What's the range of how the future might look, and how do we avoid regrettable outcomes? What are really nasty outcomes? And I can show you some as we play out mega droughts in Phoenix. And what are the policy solutions that we have that can help us to avoid them? What ifing? What are the consequences of particular decisions in a complex system? What if we impose this policy? What would be the likely outcome? What policies are the most robust? When we talk about robust policies, we're talking about policies that work best across a range of climate or growth or other futures. Some things work better than infrastructure. Conservation works better than infrastructure across a range of climate futures. What are the costs of delayed decisions? I was talking to somebody last night. What do you do with a decision-making under uncertainty problem? One of the things that you do is you separate your alternative into modules and do things, put off what you can for 5 years in the hopes that we'll know more. I don't know that we're going to know a whole lot more about the climate 5 years from now than we do today, but we can know more about how people will respond to particular policies, how hydrological systems will respond to climate conditions. So maybe there are some decisions we can put off. Some expensive infrastructure we're probably going to have to make at the beginning. But a decision-making under uncertainty problem has certain characteristics. But the characteristic I'd like you to focus on is the question I'd like to focus on is the first one. What do we as a community really want? And then what is it going to take us to get there? It's a different kind of a question than we've traditionally asked in climate and the hydrological sciences. So we wanted to be able to do some simulations. We wanted to be able to do some what-ifing. And we needed models to be able to do that. So we built, I think we're in our 6th version of WaterSim at this moment. This is a schematic of WaterSim 5.0. It shows our major water sources. It shows the opportunity for water reuse, for conservation. We can put in many of the policy decisions that interest us in this rather simple water resource model, but this is the one we've built and we've refined, and with a lot of stakeholder engagement. So our stakeholders hated this at the beginning. I mean, we build a model and they come in and they'd say, well, how did you do this? How did you do that? What's under the hood? And we spent about a couple of years trying to explain how we measured things and how we modeled it. And I think after, it took us a couple years to get people that actually have some belief and investment in this model. And more importantly, we asked them, what are the issues that are most important to you, that you think, how should we fix the model? So to try to earn some investment. If we made a mistake, it was trying to build the model right off. I think we wanted to have something to show people, so we built the model right off, and always with the understanding that we're going to fix this, we're going to change this once we have input. But we spent a couple of years trying to dig ourselves out of that hole. So we have a water resources model that we use. We show it in that decision theater that I showed you at the beginning. And what we've learned is to simplify the inputs and the outputs, that the inputs that we allow people to be able to manipulate. So we have policy, we think in terms of policy choices. So people can make how much water should we reuse? We reuse about 60% of water now, and infrastructure limits us from doing more. But the insanity of using potable water to maintain these landscapes gives us belief that there is more to be gained from moving to 100% on that lever bar. We also have, we allow people to, agricultural land is being transitioned into urban uses. We'll gain some benefit there. As of this point, water in the West is for the most part, the Western USA is for the most part a commodity with minimal amounts set aside for environmental flows. The legal obligations in our state are related to the Endangered Species Act. We create a future what if. What if we restore environmental flows to 30, 40, or 50%? What would be the consequences for Phoenix's water supply if our values about environmental flows change? Per capita water use, we can reduce water from conservation and population growth. We can impose some population controls and see what that does. And then we can look at outputs at the top. What are the sustainability, we're calling them the sustainability outcomes associated with those decisions, to get people talking about how we might address that bathtub ring that I showed you a few moments ago. We do this in the decision theater, and I don't think we see the decision theater as a place where we speak and people listen. It's a place where people argue about, is it going to be, is our priority going to be environmental flows or growth, or how important is it for us to conserve water in the next year? And put that in the model, they'll say, and then we'll see what comes out. So this is a place where that can happen, this decision theater. The problem that I wanted to show you here is, this is the paleo record, and the paleo record shows that we had a severe drought condition in about the 1100s. And there's a great deal of talk in California now about the possibility of a mega drought. So what we've done is to put that mega drought into our water simulation model. We've reduced the water flows from the watershed immediately north of Phoenix, as well as from the Colorado River. We've imposed all the rules of Colorado River allocation that give us junior rights. And we've begun to think about what it would mean for us if those 11th century, this is not climate change, and this is important when we interact with our stakeholders. These are the facts. This is what pertained in this region, and we know this from tree ring data. So this is what would happen in terms of we pay a lot of attention to our groundwater, because in a place like Phoenix, groundwater is a bank, and it's historically been a bank that we use, that has been used to maintain water use when the surface supplies have been in deficit. This has gone on for 100 years as part of an agricultural society, and this is one way to think about it as an urban society. So our dependent variable here is the changes in our groundwater levels. Our state law, it's not enforced, but we have a groundwater management act that stipulates that there must be 100 years of available groundwater to support any new residential or industrial development. So the law says that we've got to have 100 years. So we focus on this groundwater because of its historic, it's a sustainability measure. It's historically been a bank. It's also buttressed by law, imperfectly enforced, but a law, one that could be law nonetheless. And what we do is, and I know I'm going over time. What we do is to simulate this over time under business as usual conditions, assuming growth, and under mega drought conditions, those 11th century conditions, and look at what would happen to the level. 90% of the outcomes fall into this category, which means that, would fall into the shaded area, which means that 10% would fall either a small amount above and mostly below. So mega drought decreases our, first of all, groundwater or mega drought decreases our groundwater levels, but what it does, and people seem really interested in it, what it does is to greatly increase the interannual variability of our groundwater supplies. What we also did is a sensitivity analysis to 5 policy features that we think groundwater is sensitive to. Growth, conservation, we could bank our water, we could take the extra water that we receive in excess years from the Colorado River and bank it in our underground aquifers, and we do that now. We can reuse, we can raise reuse from 60% to 100%. And finally, and there's serious discussions about this, water augmentation, build a desalinization plant. We would build a desalinization plant on the coast of California, give California, very expensive, give California that water, and take California's Colorado River flow for ourselves, to negotiate that. So we include that as a policy option. It's an expensive one, and we think about how sensitive in these 5 charts the system is to the groundwater system is to these policy interventions. I'd like to address your attention to this first one. This is in a no-growth world. Our groundwater, we would maintain 100 years of groundwater supplies during a mega drought condition. It's going from 4 to 8 million. That's going to stress the system by our reckoning. Conservation buys us time. Our groundwater system is sensitive to conservation, and the more we do, the more surplus that we are able to achieve. the water banking. Water banking helps us in some of the really tough years. It evens out the aquifer balance. The water treatment buys us more time, and water augmentation really is a help in the difficult years. I'll just again, I don't want to talk about the gory details, but I'd like to show you. We've also tried kind of an experiment with. You can look at those policies individually, but what's interesting to us is in various combinations. So I'm just going to show you a combination where we're looking at deficits in the groundwater over the 60-year simulation period under a 75% growth scenario. So we experienced some real uncertainties associated with the groundwater supply if we continue to grow at the rates that we're growing now. Growth is a critical issue for us. We'd experienced some significant uncertainty. Think of these light blue areas as zones of uncertainty. We experienced that uncertainty even with conservation and growth. If we add banking to the picture, we can pretty much, some of that expensive infrastructure starts to buy us security from one year to the next. Reuse buys us a little more, and with augmentation, we would essentially have 100 years of water supply, and we could sustain that over the long term, even with 75% growth. So, what are the conclusions? I mean, we can change the order in which these policy variables are added. We can change 75% to 50%, depending on whatever people want to talk about. This package of policies. This is the package that's on the table in the news media in public discussion now. So we didn't pull this stuff out of thin air. We rather pull it from we had people do a discourse analysis of what were the topics of conversation and what thus should we put into our model. I think in terms of what would I like to leave you with? It's not that there's any one particular course of action for Phoenix, but I think there's growing uncertainty associated with, and we see it in the bathtub ring a couple of times a month. There's growing uncertainty about our water supply and capacity to continue to maintain growth and to maintain the lifestyles that now dominate the urban geography landscape. I don't think those predicting. I don't know that predicting the future is going to do us a whole lot of good, given the uncertainty associated with growth and the uncertainty associated with climate. And I think we've come to believe that we're a whole lot more comfortable with this exploratory modeling. We're willing to concede there's no one best answer. You tell us what you want to know, and we can gin it up in our water sim and give you a range of answers to elicit public discussion. So these scenarios that we've created for the megadrop condition, I think are an example. Vulnerability tests. I certainly think that the stability, the sustainability of Phoenix's groundwater is vulnerable to both to continued growth and to uncertainties associated with climate, and that's not a very popular message where I live. I think we're hopefully responding to the National Science Foundation challenge to be able to manage uncertainty. We're hoping that our models are used for public discussion and that provide something for people to chew on, to talk about, to do more than talk about water reuse, but to have an estimate of what water reuse can achieve versus conservation. So people can begin to have a serious science-based, evidence-based understanding of what that trade-off means when we manage the water that we have in any given year. Again, I think we've been moderately successful in people now are talking about the future of the city and what we'd like to. How much vulnerability reduction we would be willing to tolerate, what the city might look like if we use less water for decoration and for human comfort. I don't think I wouldn't like to believe that science is not I think science is a major player in this game, but it's not the only player. And it's a player in a cooperative game. And as part of that cooperative game, we're hopefully improving the public discussion and the ultimate trade-offs and the decisions. They are going to be trade-offs because there isn't any more water. So if we want to have more growth, we're going to have to give something up, and it's a question of what we're going to give up, and that's not a science question. That's a public question. Do we want to be part of that public conversation? I guess we talked about a couple of months ago takes a lot of time and can be a lot of fun, but it's certainly a core part of this process for us. So thank you very much for your attention.